Alright, here's another example for you. Let's solve this thing using the quadratic formula. Now, first of all, since I worked this thing out ahead of time, I know that the answers are going to be imaginary. So let's talk just for a minute about how to simplify or work with uh, expressions that are actually imaginary numbers. So as you may know, typically we think of I as the square root of -1, right? That's the imaginary unit. It has the property that if you square it, you get -1, right? It's just a quick review. Now, if you have something that looks like this, right? The square root of -k, then you can rewrite this with the imaginary part explicit in this way, I times the square root of k. So here's an example. Square root of -2 is I times the square root of 2, right? Sometimes you have something like this, the square root of -4. That's going to be I times the square root of 4. But the square root of 4 can be further simplified, right? That's 2, right? So that's actually I times 2, and we write that as 2I. Okay, how about something like this? Square root of -8. Well, that's I times the square root of 8. Now, you all probably know that the square root of 8 is 2 square root 2. But how do we figure that out? It's because 8 is 4 times 2, right? And that's the square root of 4 times the square root of 2. Now the square root of 4 is just 2, so this is I times 2 times the square root of 2, right? And typically we write that as 2I square root 2. Okay? So, let's get on with this problem. Now, the first thing you're going to want to do in any quadratic equation, unless you're going to apply the square root method, is to get one side equal to 0. So we need to get 0 on one side, and the quickest way I see to do that is to add x squared to both sides here, like that. Now minus x squared plus x squared is 0. I'm going to write this all in sort of the standard order. X squared plus 5x plus 7. All right, now we can apply the quadratic formula. What is a? A is 1, right? It's the coefficient of x squared. What is b? 5, the coefficient of x, right? What is c? 7. So what is the discriminant? B squared minus 4ac. It's 5 squared minus 4 times 1 times 7, right? Like that. Now what's that? 4 times 1 times 7 is 28, so it's 25 minus 28, which is -3. Now notice that the discriminant came out to be negative. So whenever that happens, right, that means that the discriminant is the thing underneath the radical. So if you get a negative under the radical, that's where all this business comes in with imaginary numbers, right? Notice that in all these examples I did beforehand, I had a negative under the radical, okay? That's really where imaginary numbers come from, all right? Negatives under radicals. So because b squared minus 4ac is the part of the quadratic formula that's underneath the radical, when it comes out to be negative, like in this case, we know our solutions are going to be imaginary. All right, so let's write out the solutions according to the quadratic formula. X is negative b. What was b? 5, right? So -5 plus or minus radical, the square root sign, with the discriminant underneath it, all right? -3. Okay. And over 2 times a. What was a? 1. Okay. So that's -5 plus or minus. What's the square root of -3? Well, I follow this pattern here, right? I square root 3. And 2 times 1 is 2. And that's a pretty good answer right there. Now, a lot of times you'll see books and whatnot go a step further. They break this up into a sum and difference of two fractions like this. -5 over 2 plus or minus I square root 3 over 2, like that. And then sometimes they go even further and they do like this. Like that. Okay, so the two solutions are actually written as a set sometimes, like this, -5 over 2 plus square root 3 over 2i, and then -5 over 2 minus square root 3 over 2i. That's, a very formal way of writing out the solution set. Okay. So again, well, the reason, one last note, the reason that they write this way is that it's considered this form right here, a plus bi, that's considered sort of a standard form for any imaginary number. So like here we have this, a real number plus another real number and then times I. That's the form. It's not necessary, strictly speaking, to do that, but you may want to keep that in mind for, when you're working out, online homework and stuff like that. It may expect it to be, the imaginary solutions to be in this form, right? And again, it's like real number plus real number times imaginary I, like just the I times I. All right, real number plus real number I. All right, hope that helped.